Hi guys, in this video we are going to take a look at question 11, and in this question we are trying to figure out 2 points on the circle x squared plus y squared equal 20 that are closest and farthest from point 1, 2, and we want to specifically use Lagrange multipliers method. So just to show you the picture, I want to introduce the graphical representation of the problem. So here we have a point 1, 2, and we're looking for 2 points. One of them is going to be somewhere over here on the circle. It has to belong to the circle. That would be closest to 1, 2. And then the other one is going to be on the other side somewhere over here. That will be the furthest from 1, 2. But generally speaking, you have a point with coordinates x, y, and we know that it satisfies the constraint x squared plus y squared equals 20, which usually we'll call this function g. That's the constraint. But function f is the function we're trying to maximize and or minimize. In this case, we actually want both. So in this case, what we want is we want to maximize and minimize the distance from 1, 2. And the distance formula looks like this. You take a point with arbitrary coordinates x and y, and you subtract a 1 and subtract 2 from the y and square them. And generally speaking, you have to take the square root if you're talking about distance itself. But here I prefer to use the squared distance as opposed to distance itself. It can be shown that whichever point, wherever the maximum will occur, it'll occur at the same exact point whether you are taking the square root or you're not taking the square root. So just not taking the square root and considering the square distance is just easier in terms of taking the derivative. That's the only reason I am doing that. And it can be shown that it's equivalent. Okay, so the gradients of f is just going to be 2 times x minus 1, right? The derivative of something squared is 2 times the something multiplied by the something with respect to x, but x minus 1 derivative is just 1. So that's just going to be 2 times x minus 1. The second term does not have an x, so that'll just become 0. And then over here, that'll be similar, and that'll be 2 times y minus 2. Now for g function, which is x squared plus y squared minus 20, we usually want to keep everything on the left and 0 on the right, which is the constraint. That's just going to be 2x and 2y. Okay, next for Lagrange multipliers method, what you want is you want the two gradients to be proportionate to each other. And generally, you need to use what's called lambdas, which are Lagrange multipliers themselves. However, in application problems, and that's why I like them so much, it really doesn't usually happen that either x or y are 0. And you can show that over here if you look at the picture. X and y, neither x and y are 0. So we don't have to worry about division by 0. So all we really want to do is just find out when these two vectors are proportionate, and that can be done by just dividing their x components and dividing their y components and setting that equal to each other. Now we can see that 2 will cancel here, all right? And then we're going to cross multiply. So we're going to multiply x minus 1 by y in parentheses, and then x times y minus 2 to solve the proportion. Now, a lot of times here we will see some terms canceling. So I got xy minus y equals xy minus 2x. So subtracting 2x from both sides, actually no, subtracting xy from both sides will cancel it. Okay, and so then I get negative y equals negative 2x, which is the same thing as saying that y equals 2x. Okay, so here, using this proportion, we were able to connect x and y, but we still haven't used the constraint. So remember that you always have to go back to the constraint at the end of the problem. And x squared plus y squared equal 20, we're going to substitute 2x for y. So that'll give me x squared plus, now when 2x is squared, be very careful, the 2 is squared, which is 4, and x is squared. Okay, so I got 5x squared equals 20. If I divide both sides by 5, it looks like I got x squared equals 4. So in my case, I actually got a nice answer, but you don't have to. If you get some square root of 5 or square root of 7, whatever, just leave it like that. For me, though, I have 2. And also -2, because when you square a number, the negative goes away. So it looks like for me, I have x equals 2 and x equals -2. But what about y? Well, we remember that there was a connection between y and x, y equals to x. So we're just gonna double each coordinate. So that's just gonna be 4. And then we're gonna double this one, so that'll be -4. So my points are 2, 4, and -2, -4. Okay, so let's see if we can put that here. If you have your square roots, just put them just like that. Now, why am I putting 2, 4 as a closest point? I just look at it geometrically. I can see that this point with positive coordinates is closest, and the other one is with negative coordinates. But you can tell by looking at the distances. Whichever one is smaller, that's going to be the closest, and the other one will be the furthest. Now, how do we find the distance? So to find the distance, you need the distance formula. So let me put it side by side over here, because we want the distance between 1, 2 and this point. And then you need to round it to 2 decimal places. So let's see if we can do that. Now, here we're not finding square distance. We're actually finding the distance itself. So we do have to take the square root. So we're going to subtract the x coordinates, subtract the y coordinates. So looks like I got 5. So my distance is going to be square root of 5, but so don't forget to put square root and round to 2 decimal places. So I got 2.34 for the distance to 1, 2. And then for the other one, -2, -4. So let's do that. Oh, oops, -2 and -4. And I got 45. What is square root of 45? That's something like 6.71. So you can see that this point definitely was closest and this is the furthest. Okay, so I don't know why this is not mistyped. All right, now it's all good.